Let us study about galvanometer. We already studied that a galvanometer is a deflection type meter. About this we can write it is used to measure small currents in different branches of circuit. Because its capacity is for lower current only. For high currents we cannot use a galvanometer because it gets damaged by the heat produced by high currents. And about galvanometer we can say a galvanometer has two standard characteristics. These are, the very first one is full deflection current, which is denoted by Ig, and the second one is its coil resistance, which is denoted by Rg. Now, if we talk just about full deflection current, it is the current when passed through a galvanometer, its needle is deflected by the full scale. Just to understand, let's have a look on this galvanometer. Here you can see when a current less than Ig flows through the galvanometer, the deflection of needle is less than the full scale deflection, and when the current passes through the galvanometer is equals to Ig. Here you can see the needle is deflected by full scale, that is up to the range which it can measure. And coil resistance is basically the resistance of inner coil of galvanometer through which current is passed. So, if this resistance has a resistance Rg, and whenever the current is passed through the galvanometer, this has to pass through the coil also. So, always whenever a galvanometer is connected in a circuit, we always consider a resistance Rg is connected in series in that branch where galvanometer is connected. We can write that an ideal galvanometer should have a zero coil resistance, but if we talk about lab galvanometers are represented as galvanometer with the coil resistance Rg in series combination. So always we consider this coil resistance in series with the galvanometer. So always remember that whenever a galvanometer is connected in series or in any branch of a circuit, always its internal resistance or a coil resistance is connected in series with the circuit, which will certainly affect the value of current up to some extent. One more thing which is important to be noted here about galvanometers is that galvanometers are available in two variants. One is a unidirectional, other is a bidirectional. Here in this picture, the galvanometer you can see is a bidirectional galvanometer, because you can see here initially the needle is kept at 0, which is at the middle of the scale. And as here current was flowing from left to right, the needle was deflecting from 0 to right. And if current flows from right to left, the needle will deflect from 0 to left. That means such a bidirectional galvanometer can also be used to measure the direction of current as well as the magnitude of current it is giving on a scale. And if we use a unidirectional galvanometer, now you can see this picture shows a unidirectional galvanometer in which the needle is kept at the extreme left end of the galvanometer, which is the 0 of its scale. But in such galvanometers we can see the range is more, but we cannot measure the direction. It will measure current only when it flows from left side to right side. But whereas in bidirectional galvanometer we can measure current as well as direction, but the range of a bidirectional galvanometer is half of the range of unidirectional galvanometer.